you can say the Python files which I've worked upon. So this is how you can go and work with the Google Colab. So I'll be directly redirecting to this particular notebook. So I hope all of you are clear, like how to work with the Google Colab, and make sure that your account is already signed in, your Gmail account. So this is a very interactive tool. Like I'll just show you like how interactive it is. I hope this is clear to everyone, guys. Like what is the usage of the Google Colab, right? This we have discussed in the previous session. Okay. So guys, let us start with today's class, since it's already 8 o'clock. So I'll be just starting sharp at 8. So I hope all of you remember the data set that we discussed in the previous session, data.csv. So this is the data that we have discussed. So like initially, I'm just going with the quick recap. So these are 3 libraries that we have imported. NumPy as NP. NP is the shortcut name of the library NumPy, and like matplotlib is another library which is generally used for plotting the graph. So pyplot is the module, and this complete thing is named as PLT as a shortcut. Pandas is generally used in order to read each and every data frame, like reading the file, writing the file. So we use pandas as PD. So PD is the nickname, or you can say the short name for the pandas. So we call this library. And using pt.read.csv, since this data.csv is already uploaded in the Google Colab, so pt.read_.csv will store this particular you can say table inside the data set variable. So this is the one usage. Guys, can you please give me a quick confirmation what were the dependent variables and what were the independent variables, just based on the field names? Can you please tell me what were the field names? Please write it on the chat box. So what were the fields which were dependent variable? Guys, can you please tell me what were the fields that were dependent variable, that was having the dependent variable? Please be with me, guys. Purchase was dependent, right? And independent, rest other variable were independent variable, right? Okay, perfect, perfect. So the thing is, over here, right? I have just called X variable, as you can see out here. I've just called the X variable as the, you can say, dependent variable, and Y variable as the independent variable. So why I'm using the colon? So colon is generally used for slicing. Since I can easily figure out that some of you were not clear with the slicing, so I'll be covering in the following classes, like how to slice tuples, list, and various strings in Python. So there is a way of doing this. So ilog will generally parse through each and every value which is present inside the data frame. So for this, I'm just calling from country to salary and excluding the purchase part. And this is only including the purchase part, the Y column, right? So I run this. Now, let us have a quick walkthrough, like what was X? So this was my X. So it contains all the fields from country, age, and salary, right? And this was my dependent variable or the target variable. So yeah, no, yes, no, no. So as you can see over here, no, yes, no, no, yes, yes, no, yes. So this is you can say the dependent variable. So I hope all of you are clear with this. And we replaced the value of like we have there were some missing fields. As you can see, there is a missing field in this pane, and there is also a missing field in the salary. So in the previous session, I replaced the missing field with the average of the rest other fields. Similarly, from here, like what is the average of all the things which is present in the age? So it will be replaced by using this command. And similarly for the salary. So I'm using there is a famous library which is called as sklearn or the scikit-learn. So I'm just calling out the module impute, and I am from the module I'm just calling simple imputer. So now this simple imputer, as you can see, this new identifier I have called as imputer. So this simple imputer will check whether it has a missing value or not. So this particular thing is actually calling to the Python that whether it has a missing value or not, and what is the strategy. So the strategy is it should be replaced by the mean. As we can see that see, there is two things: imputing and fitting. Imputing, fitting, and transform, right? So what fitting is doing, it is fitting the average and under the missing field. So the missing field were age and the salary. So this particular block of code is updating the value or inserting the value. I hope all of you are clear with this particular line. And why I've used 1, 2, 3, because it is only depicting age and the salary. I hope all of you are clear with this. Guys, it is only depicting the age and the salary. And similarly, I have written for this as well, because this is only representing the age and the salary. So this is a way of calling, you can say, the specific field which I want. So I'm just doing a column wise calling. Before the comma is the rows, after the comma is the column. So it is a column wise calling. You can also call using the rows. So it is based on the element calling. We'll be learning that in the subsequent classes, guys. And now let's have, so I hope all of you are clear with also with this imputed or transform. So this is transforming the value with the average. This is calculating the average dot fit, and this is transforming or updating the value. I hope this is clear to everyone. Okay, guys, please give a quick, perfect guys. Now in the print text, what we are printing, we are just printing the updated part. So we can see like, okay, I have to call this first. Now if I call this, so you can see the value have been updated. From the NaN, it is been updated with the average of the fields or the column values, right? Now let's talk about something on the categorical data. So before moving on to the categorical data, I have asked you to like, what do we mean by how many types of data exist, right? So I asked you to do some pre-work. So I just prepared one note in order to show you what kind of data we have. So we have an ordinal data, we have nominal data, we have discrete data, and we have continuous data. So guys, ordinal data is something like some survey which is based on like how satisfied you are. Like it can be done to the people who are working in customer analytics and like wanted to understand like how satisfied their customer are. So they will be having or they will be collecting the ordinal data during the time of survey. So like how very happy, unhappy, okay, happy, and very happy. So this can be like encoded with some numbers like 1, 2, 3, 4, 5, right? So here we will also be utilizing the concept of one hot encoding. So what do we mean by one hot encoding is replacing the, you can say that, I'll just write it over here. So generally one hot encoding is replacing the name or the string or some sentence with some number. If it has some you can say some category, right? So I hope all of you are clear with this. Like, what do we mean by ordinal data? Yes, Shoaib, exactly correct. It tells the position or rank of the data. So we can encode that on the basis of ranking also. Like very happy is a highest score. So you can say a particular customer with the highest rank is the most happy customer. So like this way you can also do or also relate it to business analytics as well. Like if you want to have a survey how satisfied your customer are, so you can encode that with the score, right? I hope all of you are clear with this. What do we mean by ordinal data, guys? Can you all give me a quick confirmation? The yes or no? You have to be very active on the chat, guys. Perfect, guys. Perfect. Now you can also see nominal data is something which is based on categories also. But these are category under some sub. You can say there is a category and there are some subcategories, right? So you can have male and female. So like male can be one, female can be two, or male can be two, female can be one. So while performing some regression techniques, like let's say if I want to perform a linear regression, and I also have a nominal data with me, right? So in that particular sense, it is very important to convert my data into codes, because you cannot perform linear regression on categorical data if it is not encoded. So it is very important before going or before performing any machine learning algorithms or techniques. So you have to pre-process the data. So it is a fundamental step. So I hope all of you are clear with this. So something like male and female. What is your hair color, like black, brown, blonde, gray, or other, right? So this is not based on score. So I'm not saying that gray will have the most score, but over here, based on the scoring, you can say that this particular based on the more score, you can identify whether my customer is happy or not. But over here, I cannot based on any score, I cannot figure out anything. So it is only based on the category. I hope all of you are clear with this. What is the basic difference between ordinal data and the nominal data? Guys, please be like active on it. Okay, perfect, guys. Now the thing is that there is another data set which I wanted to show, which is called as discrete data. So discrete data is a count that can be made more precisely. Typically, it involves integer. Like they have given you one example, like number of children in the family, because you are counting whole, indivisible entity. You cannot have 2.5 kids or 1.3 pets. So I hope all of you are clear. Like what do we mean by discrete data? Like how many burger you eat, what is the total amount of you can say clothes you buy. You cannot buy half the clothes, you cannot buy half the burger, right? So it will be an integer. So guys, I hope this is clear to everyone. What do we mean by discrete data? Okay, now let us take what do we mean by continuous data. So continuous data is something which is related with height. Let's say height can be 6 feet 1 inches, it can be 6 feet 1.4 inches, 6 feet 1.5 inches. So you can say you can categorize a height in on a continuous scale on the number line. So it does not have a break, right? So there can be two-person, or there can be n number of people with different heights, right? And all the heights can be unique. Either it can be 6 feet, 6.1 feet, 6.215, right? So it does not have any break. So you can say this kind of data is called as continuous data. So you can say the height can be one of the example, and like some scales we have in height like meter, centimeter, millimeter, and beyond. I hope this is clear to everyone, guys. What is a continuous data? Continuous can take any value, right? Continuous can take any value. Discrete will be an integer. Ordinal data is based on giving some numbers or some you can say some particular number to the categories, like male can be encoded as 1, female can be encoded as 2. Where do you live can be encoded as A, B, C based on our requirement. And like, how do you feel today? Happy and happy, okay, happy and very happy. So ordinal data is generally representing, you can say, the more the score, you can say the better your analytics. So very happy is the highest score. So you can say like, let's say if you are performing the customer analytics and you got the most score, so you can say that this particular customer is the most happy customer out of all the customer which were there. So guys, this is my ordinal data. I hope all of you are clear with the types of data. So over here, we will be generally be representing with all these types of data in machine learning, right? I hope this is clear to everyone, guys. Can you please give me a quick confirmation? I can proceed further. Okay, perfect. Sure, please write your question in like the chat box. Now, if you all are clear, so guys, let us do one thing. Let us move on to the coding part. So now let us, I'll just show you. Okay, Vaishnavi, I'll just show you the cardinal data as well. But as of now, we are majorly dealing with these 4 categories of the data. There are also some data based on the ratio. Yes, nominal is also like a categorical data itself. See, any data can be regarded as 2 kind of data. Uh, you got continuous data or the categorical data. Categorical data can have further some categories, but if you generalize the data, so nominal data, ordinal data, you also have cardinal data. So it is based on some ratio thing. So I'll be letting you know in the subsequent classes. You also have continuous data and discrete data. So these are the data set that we will be dealing in like while importing the file on the Python. So I hope all of you are clear with this. Now let us start with encoding categorical data. So what do I mean by encoding a categorical data? This
Silence.
particular data set, like you can say France, Spain, and Germany, this will be encoded with some number. So it will be encoded with some unique identity, which is like this France will be same as this France. So they will be encoded with a unique identity in a particular column. Similarly, we can also encode the purchase parts because there are only 2 categorical data which are present. If I say age and salary, these are the continuous data. And the categorical data are country and the purchased. I hope this is clear to everyone, guys. Okay, perfect, guys, perfect. Now, guys, let's have a look into this. I'll be just starting with the independent variable. So independent variable, I'm just talking about the purchase part, right? So I've already called the value of X and the Y, right? Okay, sorry, the independent variable is my country, age, and the salary. I hope this is clear to everyone, guys. Now the X is also updated with the missing values. This is one thing. So let me like just add one cell and just underneath it. But just by clicking the code, and if you are present on this particular block of you can say particular cell, so it will add another cell just underneath it. You can also adjust the positioning of the cell, like up and down. That's why this collab is a very interactive environment in order to code. So I'll be using another module from scikit-learn since I have to like complete this topic from sklearn.compose. So this is a like compose is another module from the scikit-learn. It is generally used for doing the encoding. So I'll be importing using updated data you don't see on the table because this was a raw data that you have stored. So whatever the computation that you are just doing on the Python itself. You are updating it, but it will not change my raw data. It will remain the same. I hope this clears your query, Shoaib. Okay. So guys, I'll be importing column transformer. So so you can see it is already predicting the values, but I'm intending to write. So sklearn.compose. From this module, this is called column transformer. So generally my column transformer is transforming my columns, right? Which is country, age, and the salary, right? So I'll be just doing the one hot encoding. It's very important to pre-process the data from sklearn dot pre-processing. So you can see this is already predicting. So I'll be importing one hot encoder. So this is generally used in order to replace the value with whatever the, you can say, the symbol we want, right? So let me write like a particular variable, let's say CT. CT stands for the column transformer. So you can see I'm just following some pattern like simple imputer, the variable I've called column transformer CT, right? So like this is a global way of writing the code, the clean code. So this will come with practice. Guys, if you have muted your muted, if your mics are open, so kindly mute it. Okay, so I'll be using transformer. So transformer is one of the like transformers. So transformers is one of the, you can say, the function which is used to transform you can say the column with the encoded part. So I'll be using the square bracket then followed by the parenthesis. So I'll be calling the command which is encoder. So encoder is generally used for encoding the number. So I'll be using one hot encoder. So let me cut this. I think one hot encoder. And okay. So guys, I'll be using the one hot encoder. And the another argument would be like I'll be replacing with the, let's say, with a unique number, let's say 100011. So I'm just showing you a demonstration like this can be replaced with other encoding as well, and the remainder, so which is not categorical, will parse through. Pragati, I'm just coming. Let me just write the code first. I'll just come to your query. Let me first of all be finished with the block of code. Okay, so basically your one hot encoder is generally it is encoding a categorical variable with some value or with some encoded part. Like let's say my France can be encoded with some unique identity. It can be like 100011, or it can be regarded as 123. So based on like what kind of encoding you wanted to do, right? So one hot encoder is one of the module from the sklearn pre-processing. As you can see over here, scikit-learn is a library, module is pre-processing, and from that module you are also importing one hot encoder. So this is goes like this: library, module, and from this particular module you are encoding or you are importing another function or another library which is one hot encoder. So I hope this makes sense. Like how we are actually calling out the values. Can you give me a quick confirmation? Like, are you all clear with this part? I'll just show you the output. Perfect, perfect. Now let's say X. Now I'll be using np.np for the numpy. So can you tell guys? Can you please tell me what do you mean by array? Can you please give me a quick confirmation? What do we mean by an array? I just wanted to know, like, do you have any idea what is an array? Correct. Collection of data. Correct. All types of data. Correct. So basically, I'm just you can see in our table we have categorical data and as well as continuous data. So generally, it is that only, right? I hope this is clear to everyone. Now, see, what I'm doing, I'm just transforming and fit. So there are two methods. First is the transformation of the data with the encoded part, then fitting the values, right? So I'll be just doing the column transfer to each and every values. So ct dot fit underscore transform. So let me run this block of code. Okay. Okay, it executed properly. Now, like, let me show you the output. So guys, you can see now if I show you, if you compare the data. Now guys, over here you can see like this is the unique identification. It did not do anything to the categorical continuous data, but it did a modification to the you can say the categorical data. So you can say the France is being replaced with a unique identity which is 100. So you got France over here, 1, 2, 3, 4, 5, and 6. Now if you refer 1, 2, 3, 4, 5, and 6. Now this value and the sixth value is same because we have encoded France with a unique identity which is 100. Similarly, my Spain is 001 and my Germany is 010. So I hope this is clear to everyone, like what one hot encoding is done, what one hot encoding is doing. Can you please give me a quick confirmation with the yes or no? See, don't be scared with a block of code. This will come with the practice, but like what exactly it is happening, are you all clear with it? Just give me a quick confirmation. Yeah, because it was see, the heading is independent variable. Now, after this, we will be encoding the dependent variable. Okay, fine. Because we are, see, first thing, we are only planning to encode the categorical value variables. So we have categorical variable as country and purchased, right? Now this country as a categorical variable comes under independent variable. Now this purchase comes under the dependent variable, right? Now we are actually focusing on the independent variable, guys, right? Correct? So we are actually focusing on the independent variable. Now I'm just playing with some modules and the libraries, right? I'll just have a quick walkthrough. I think Ananta is not clear, so I'll just give a quick glimpse what we have done. So Ananta, what we have done, like I've just called a module which is named as compose from the scikit-learn, and I have just imported a library from this module which is column transformer. So it will transform the column, right? And after this, I have just used a module which is named as preprocessing, and I've used one hot encoder. So what one hot encoder is doing, as you can see while just clicking on this, it is also getting highlighted. So one hot encoder, what it will do, it will see, I'll just show you like, if I click on this, so you can see Each encode categorical feature as one hot numeric array. The input of the transformer should be like array of integer or strings. So basically, in very simple words, it will transform my categorical data with some numeric values. I hope this is clear to everyone, like what one hot encoder is doing. And column transform I am using. So I'm just using a shortcut which is CT, and I am naming the column transform as CT only, right? I'm using transformer. So this is a function which I am utilizing, which is the encoder. So I'm using the one hot encoder, right? For the index number 0. So this is the index 0, 1 and 2. So I'm just using the one hot encoder for index 0. See, in Python, we have indexes something like 0, 1, 2, and 3. So I'm just doing that. I'm just intending to do my one hot encoding in this 0 index. And for the remainder pass through, I don't want to do any encoding. I hope this is clear to everyone. One hot encoding for 0, which is present at the index 0, which is my country. And for the remainder pass through, I don't want to do any encoding. So this is a very simple block of code. And np.array, so transforming the data. After doing this, after doing the transformer, I'm just fitting the values, right? So after running this, I'm getting the encoded part. So I hope all of you are clear with one hot encoding. Okay. Now guys, I'll just show you, like, let us try to do like one hot encoding on you can say the dependent variable. So I'll just click this cell. Parse through means I don't want to do the encoding for age and the salary. Correct, Pragati. Now again, for the dependent variable, I'm just I am interested in, like, you can say only the purchased column, because that is the only dependent variable and it is the categorical variable. And for that, I do not need to do any kind of, like, you can say any kind of indexing, because it's only the one column which is present. So what I'm doing from sklearn dot preprocessing, I'll be importing label encoder. So you can see this is one module. So label encoder will just label the data in the format of 1 and 0. I'll just show you the output. So LE for the label encoder. See, this is a universal way of writing label encoder. So I'll just use the small initials LE. So label encoder. So now my LE is my label encoder. You can say library from the module sklearn preprocessing, or from preprocessing module of sklearn. I have just imported a library label encoder. So y is equal to le dot fit. So I am just utilizing a function which is fit and transform. See, in this set, I've just transformed, then I have fitted, right? So this will directly do the same computation which I have done previously, right? So this will encode my, you can see the data set. It is present as no and yeses. So it'll be encoded as some numbers in the format of 0 and 1. So I'll just show you the output. And let me have one more cell. Print y. So guys, you can see now this part is being encoded. No with a 0, yes with a 1. Then you got two no's, so two zeros, two yeses, so 2, 1. Then a no, then 0. Yes for 1, 0 for no, and 1 for yes. I hope this is clear to everyone, guys. See, you can see there is an anomaly in both the code. only this label encoder, what label encoder is doing, it is updating the value no with a 0 and yes with a 1. But see, the thing is, over here you got more than one categories like Spain, Germany, and France. So I cannot use 0 and 1. So I'll be using one hot encoding. So what one hot encoder will do, it will give some unique number. So something like unique identity, something like 100001. So I hope this is clear to everyone. Guys, I hope this is clear to everyone. Now let us focus on splitting the data. We can use that, but it is preferred that we generally use label encoder for dependent variable. But it also depends on the type of data. This is a very simple data. In real world, you will be getting much more complex data. Vaishnavi, right? I hope this clears your query. Okay, now guys, let us focus on this is one of the fundamental step in like machine learning or like data science. People always go for splitting the data into the training set and test set. Now listen to it very carefully. Why do we do the splitting the data onto the training set on the test set? Yes, yes, correct, sure. Yes, sure. It's for the one categorical data only. Guys, now I just wanted to tell you like splitting the data set into the training set and the test set. Why do we require a training set and why do we require a test set? So generally we require training set. I'll just show you in over here. So generally we require a training set for like calculation and test set for model performance. I hope this is clear to everyone. Like, why do we require a training set? See, training set is generally, let's say if I got 10 fields and if I split the data into training set and test set, let's say 10 fields, I'm splitting the data, 80% data to the training set and 20% data to the test set. So can you tell me like out of the 10 fields, how many fields will come in the training set? If I'm doing the splitting 80 to 20, out of the 10 fields, let's say if I got 10 fields, I'm doing 80% splitting. So how many fields will come in the training set, guys? 80% of 10 is how much? Guys, can you please write? 8. Okay, perfect. So eight fields will come over here. And remaining, how many fields will come over here? 2. Isn't it? So training set is generally used in order to do all the computation, right? And model performance is in order to check how accurate is your model. Let's say if I want to predict something, if I have a past data, if I want to predict the future data, so my prediction will be based on the training set. Now, how much close to I am to the actual prediction will be determined with the test set. That will tell you that what is the accuracy of your model. I hope this is clear to everyone, guys. So we are just planning to split the data into the training set and the test set. So I'll just write a block of code. So like, see, that's why I told you in the previous class also, like sklearn is one of the powerful libraries, which is and most highly used libraries in the Python data science. So see, model selection is one module from the scikit-learn library. So from this module, I'll be importing one library which is train test split. So train test split is one library which is or the one another module which is used to split the data into the training set or the test set. So there is a way of writing x train X test. So X train is for the training data of the independent variable and the training data, testing data of the independent variable. Y train. So Y train is for the training data of the dependent variable and Y test. It's a very simple block of code, guys. So this will be equated to, I'll just cut it off. This will be equated to train underscore test. So these are the argument. First, my you can say the independent variables followed by dependent variables and like test size. So guys, if my test size is let's say 0.2, 20%, what would be my training size? If my test size is 0.2, what will be my training size? 0.8. So 80%, right? So I'm just splitting my test data to be 20%, right? So this is what I'm doing. So random underscore state, which is equal to 1. See, there is one particular function that you will very see oftenly in the machine learning world, which is set.seed, right? Or the random state one. So set.seed you will find in R, and random state one you will be more or less will find in Python. So random state, let's say if I'm writing random state 2 and you are writing random state 1. So there might be chances that while splitting the data, whatever the data that have been splitted, you get something else, I get something else, because we have set it the random state differently. I hope you all of you are getting my point, guys. So let's say we both are working on a similar model, right? And we wanted to get a similar output. So we all the time we have to set our random state to be the same number. You can take any number over here, right? So I'm just taking a very specific number, which is 1. I hope all of you are clear with the random state part. Can you please give me a quick confirmation, guys, with a yes or a no? Because we need a random state so that if we both are working on the same data set, so we will get the same output. Let's say if I set my random state as 2, you've set as 1, so there might be chances that I may get some different result, you may get some different result. I hope this clears everyone, guys. Okay, perfect, guys. Now I'll just run this. So the block of code have been executed properly. Now I'll just show you the test data and the training data, guys. Let me add some more cell. So I'll be requiring 4 more cells. So print x underscore train. So for the training data, so you can see now the training data have been splitted as 80%, right? The training data have been splitted as 80%. Now I'll just also compare this with the data which is already there. So guys, you can see there are 10 fields, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now over here, there has to be 8 fields because the test size is 20%. So the training size should be 80%. So 1, 2, 3, 4, 5, 6, 7, 8. I hope this is clear to everyone. And this is only have splitted the independent variables, right? I hope this is clear to everyone, guys. I'll, guys, is it clear to you, all of you, right? How the splitting is happening? Okay, perfect, Pragati. Now let us print X test. Correct, sure. Correct. So it will have only two fields, which is not included in my training data. It is included in my test data. So you won't find these number over here, right? If you combine both of them, then it will be the entire data set. Okay, now I'll just show you the, you can say print y test. First, okay, let us print the train first. I hope this is clear to everyone. It is only printing 8 fields, right? So 1, 2, 3, 4, 5, 6, 7, 8. All the fields are encoded, right? So it is not printing no and yeses because we have encoded it. So guys, I hope this is clear to everyone. Now let us print the y test. Oh, sorry, y test. So it is only printing the two variables, no and yes. So I hope this is clear to everyone. Like how, like in what way we are doing the splitting the data set. So this is a specific template. I'll be sharing you the template so that you can only need to plug in the data set, and with using the template, you can work on data pre-processing to any kind of data, right? I hope this is clear to everyone. Okay, now guys, let us move on to the next part, which is very important, which is called as feature scaling. So guys, people will tell you like we do first what splitting the data into training set or the test set, or we do the feature scaling. So always remember that always in the machine learning, we after splitting the data into the training set and the test set, we generally do feature scaling. So this a specific question that you will find very often in the data science community, right? So I'll just have a quick walkthrough. What do we mean by feature scaling? So this is one thing that is related to feature scaling. So guys, in the feature scaling, what we do, we either standardize the data or normalize the data. What do I mean by standardization of the data and the normalization of the data? See, normalization of the data is something which is meant by like my data is distributed normally, something like a bell curve, right? And standardization means just changing the value of my data from roughly around -3 to +3. I hope you are getting what I'm trying to say, guys. Changing the value from -3 to +3, it is what is called a standardization. Normalization is by just transforming my data so that the data is the normally distributed, right? I hope this is clear to everyone. Now, like where we do, why we do the feature scaling and what is the need of standardization, what is the need of normalization. Guys, in real time, you will find some outliers in the data which are present, and you might find some normalization data to present. So while applying some machine learning techniques like linear regression, logistic regression, or any of the technique, so it is very important to normalize or standardize the data. In 90% of the time, you generally standardize the data in the machine learning world, 90% of the time. Normalization of the data generally meant if other columns, let's say the columns which are present over here, let's say there are 100 columns. Let's say if my 80 columns are normalized, then what you will do to remaining 20 columns, you will normalize the data. But most of the time, you are standardizing the data. I hope this is making sense. Guys, I hope this is making sense. Like what is standardization and what is normalization? Vaishnavi, you please write it on the chat box. I'll just come to your query. Okay, so I'll just tell you how do we use standardization and how do we use the normalization. Let's say, see, these are some technique in order to perform the machine learning thing. And most of the time we do the standardization. This is one most important thing. Now I'll just tell you, let's say this is a, formula for writing the standardization. So x minus mean of x, standard deviation of x. So what it will do, I'll just tell you with the following table. Let's say it want to standardize this. So first of all, it will calculate the standard deviation of the entire data set and the mean of the x. So mean of x means the mean of the complete age block. Then it will automatically plug in the values and it will find the standardized value. I hope this is clear to everyone. For a specific field, how it is happening, right? Like let's say if you want to standardize this value, so like it will first of all find the mean of this complete data if of this complete column, and then it also find the standard deviation. Then it will subtract this particular number with the mean of the entire column and dividing it by the standard deviation of the entire column in order to get the you can say the scaling part of the scaling value of a particular cell. I hope this is clear to everyone. And the value will lie from -3 to +3 under the standardization. Guys, are you getting it? Feature scaling? Please reply with a yes or a no. Okay, perfect, perfect. I'm just letting you know like what is feature scaling. Like similarly, x, that particular field, minus the minimum number which is present and maximum minus minimum. So this is the normalization part, right? So right now in this particular data set, I'll be doing the standardization because as I mentioned earlier, it will be utilized 80% of the time in working with any module or any machine learning pre-processing. So guys, I'll be using the library which is sklearn dot pre-processing. So I'll be importing a module or the library from pre-processing sklearn, which is the standard scaler. That's why I really like this collab part. It's you can see like it is automatically predicting like because if you go to another environment, you won't find this option. And good part is you automatically all the results are automatically saved in the cloud on the Google Cloud platform. So again, SC, the small notation for the standard scaler, X underscore train. Okay, guys, the thing is, I'll be only doing the feature scaling to the part which is non-categorical, which is continuous. As you can see in the one hot encoding, this is automatically lying in the values which is lying between -3 to +3. Similarly, you can also see it for the purchase after one hot encoding. So in general, I am only focused, the feature scaling is most of the time is only performed after the one hot encoding to the, you can say the continuous variable. I hope this makes sense. Guys, can you please give me a quick confirmation? I am only doing the feature scaling to the continuous data, okay? Now I'll be just calling out the same way, the range which I've utilized earlier, as you can see over here. So let me copy this. So this is only depicting the column age and the salary. This is called as element calling. So again, sc dot fit underscore transform. So x underscore train. Again, the same element I'll be calling. So since we only are doing for the you can say the independent variable, because the continuous variable are only present on the independent variable, not on the not on the dependent variable. And we have already done the one hot encoding of the purchase column, so we are not considering it for the feature scaling. So x dot test, again the same column, sc dot transform x underscore test. Okay, so guys, this is a particular function which will transform my training data and the test data. So let me run this block of code. So I'll just show you right now the training data. So you can see the values have been one hot encoded. Guys, making sense? You can see the values are lying between -1 to -3 to +3. It is called a standardization. I hope making sense, guys. Can you give me a quick confirmation whether you are getting it? Okay, perfect, guys. Now let us do it for the test set as well. Okay, this has to be capital. I hope makes sense. Now your model is ready in order to perform the machine learning algorithm. So after doing the data pre-processing, guys, what you can do, you can like import this data and you can apply any kind of methodology like linear regression, logistic regression, totally depending on the data. So data pre-processing is one of the preliminary steps in the machine learning in the data science world. And while importing the data from research or the raw data, you have to like pre-process the data. I hope all of you are clear with this. To all of you, I'll just share you the data pre-processing template. So in the data pre-processing template, it will only involve importing the libraries, importing the data set, and taking care of missing data and the feature scaling. So this will be the data pre-processing template. Only you just need to, let's say if I don't have this data.csv, if I have something else, so what I'll do, I'll just change this. Rest everything will remain same, but what you have to do, you have to only plug and play based on the type of the data. I hope guys making sense. Any doubts, any confusion, please ask. So this is our data pre-processing template, guys. I'm just scrolling down. Please ask if you come across any doubts. I hope clear to everyone. We do feature scaling in order to like make your data ready in order to perform linear regression or logistic regression, because they do not take the raw data which is unprocessed. So it's very important to process your data, right? Guys, any doubts, any confusion? So like if we are fine with it, so I'll just call it a day for today. And like these are the things that we have covered so far. So in tomorrow's session, what I'm planning to cover, since some of you were facing some issues on like slicing, so I'll be covering a topic which is based on slicing the list tuples and the list tuples and the string. So I'll be working on list tuples and string slicing. So this will be the thing that we will be covering in the tomorrow session. I hope makes sense. Okay, yes, Pragati, I'll just share you the pre-process template on the group itself. Fine. Okay, let's call it a day, guys. Uh, Good night and keep on learning the data science.